Hello everyone, welcome to my talk. My name is Ricardo Castro and today we're going to talk about reliability. So, what do we have on the menu for today? We're going to start by giving some context about this talk. So we're going to use an example from the real world and then we're going to translate this into our techie reality. We will then talk about reliability. We are going to start step by step and we're going to develop a framework that many of you already have heard about, that surrounds around SLOs. We will then see where the real value of having such a framework in place comes from. And at the end, we're going to conclude this on why all of this is important. So let's start with an example from the real world. So an example from the real world, I'm going to be using a supermarket. If we think a little bit about it, a supermarket, it's kind of a microservices architecture. Why do I say this? So, the idea for me as a consumer, I go to a supermarket, I do my shopping, I pay, and I get out. But underneath the covers, there's a lot that needs to happen so that my consumer experience is actually reliable. So there are many different pieces that need to fit into place so that when I go to the supermarket, everything is there for me to buy. So someone has to make purchase orders to actually get products into the supermarket. Someone has to transport those products. Someone has to unload those products into the supermarket. Someone has to stock the shelves. Someone needs to be at a counter if I need some kind of assistance. Someone needs to be at a counter so that I need to pay. So as we can see, there are a lot of moving pieces inside a supermarket that have to be successful so that my simple user experience is actually reliable. So, how can I assess if a supermarket is being reliable or not? Let's see a couple of examples of how we can assess the reliability of a supermarket. So, let's imagine that we did all of our shopping and we want to pay. How can this experience be not reliable? So, if it takes too long to pay, I may assess this experience as not being reliable. By the same token, I go to a shelf, I pick up the product, and the product expiration date has passed, right? So I might assess this supermarket as not being reliable if I go to try and buy a product and I can't because the product expiration has passed. And we can draw a parallel here into our techie world. When something takes too long to pay, we can equate that to latency. So if I send a request to a service, it takes too long to receive a response back. And the same thing, if a product expiration date has passed, I can use this as an example of an error. So as an example, I'm going to use my own company as an example. So I work at a company called Anova, and we operate in the industrial IoT space. So essentially, we develop solutions for our customers to have industrial sensors. We ingest data from those sensors, and we provide create meaningful services that help them manage their own infrastructure. So essentially, this is our main focus. So we collect high reliability data from high reliability sensors. We collect that, process those services, and then provide solutions to our customers. So for this, all of this to be successful, we actually need to ensure that all of our services are actually reliable. What does reliability mean? So if we go into the Cambridge Dictionary, it has a definition of reliability as being the quality of being able to be trusted or believed because of working or behaving. And this gets me a little bit confused. But essentially, it says that something is reliable if it's behaving well, right? But I prefer the definition from Alex Hidalgo in his great book, Implementing Service Level Objectives, which essentially asks the question, is my service reliable? And how can I assess that? And basically, I can say that, is my service doing what its users needed to do? So this is a little bit of a shift. So we're not saying that something is reliable if it's behaving well. We say that something is reliable, a service, for example, if it is doing what its users expected it to do. So how can we go about developing a framework to actually ensure that services are doing what its users needed to do? And we're going to start to building this step by step. And we're going to start with the most basic component in our system, which are metrics, very well known to all of us. And essentially, a metric is a measurement about a system. It doesn't tell us anything other than a measurement. So a few examples of what a metric can be. At the amount of memory that the user is, that the server is using, for example, in terms of percentage of available memory. The time it takes for an HTTP request to be fulfilled, for example, in milliseconds or seconds. The number of errors, HTTP response errors, for example, a natural number. Or the age of a message arriving at a Kafka cluster in terms of minutes. So with metrics, we can start building on this and start evolving this concept. And the next concept is the concept of a service level indicator. And a service level indicator is a quantifiable measure of service reliability. And it helps us separate good events from bad events. So how can we define service level indicators to actually say if an event is good or bad? So here are a few examples. We're going to take the examples of metrics, and we're going to use that metric and actually define SLIs that tells us if when we look at a metric or an event described by a metric, you can say that if that metric is good or not. So we need for a binary state to be achieved, right? So we need for something to be good or bad, even if the underlying metric doesn't provide that binary state. So how can we define that? So using the previous example, we can say a request needs to be responded within 200 milliseconds. So every time we take a measurement, if it takes more than 200 milliseconds, we can say that this is not good. If it takes 200 milliseconds or less, we can say that this is good. And this is analogous to the other example. So a request to a service must not be responded with a 500 code, right? If it's responded with a 500 code, it's not okay. If it's responded with a code different than 500, it is okay. And again, same thing for messages arriving to Kafka. If the message is not older than 5 minutes, everything is okay. If the message is older than 5 minutes, things are not okay. You might need to do something. So we started with metrics. We went to SLIs. What comes next? So next is an SLO. And an SLO is nothing more than how many times one SLA has to be achieved so that I can be sure that my users are happy with my service. And that, of course, needs to be measured within a time interval. So using the same examples again, we're going to evolve an SLI into an SLO. So we can say 99% of requests to a service need to be responded within 200 milliseconds within a 30-day period. So we define an interval, which is 30 days. We look at all requests and we say that 99% of them need to be responded within 200 milliseconds. If not, I can say that my users are not being satisfied with my service. Same thing with the other examples, 99% of requests to a service need to be responded with a code different from 500 within a 7-day period. And exactly the same thing with the 4 messages arriving to Kafka. But how can we create good SLOs? So here are a few tips on how to create good SLOs. So first and foremost, and if you forget all the other tips, is the first one. Always focus on the users. Users are the one who will be defining the reliability of my service. So it makes sense for us to actually know what the user expect and track our reliability according to that. Going a little bit deeper, one good option to actually start defining SLOs is to list out critical user journeys and order them by business impact. Maybe is your search catalog, maybe is checkouts, whatever makes sense within your company. Then we need to determine which metrics we will be using as service level indicators to most accurately track that user experience. So we need to define a few metrics or measure a few things and be sure that we have SLIs that actually track what we know that the user is valuing. Also, try not to get too overboard with SLOs. For most cases, 3 or 4 SLOs should be enough, and we can use a composable metrics to do that. Also important is to have SLO documents. We'll see an example in a second, but it's essentially an SLO a document that describes what the SLO is, when it was last reviewed, and so on. Very important is to review SLOs periodically. SLOs is not something that is set in stone, and every once in a while it needs to be reviewed and to be sure that it's still actually tracking user satisfaction. And also determine SLO targets and goals and the SLO measurement period. Don't try to be too reliable. And we see what I mean by this in a bit. So just a quick glance on an example of an SLO document. This example was taken from the Google SRE book, so you can use it as a reference to build your own and adapt to your own reality. So essentially, it has a description of the SLO. So this is an SLO for the example game service. It has the authors, when it was defined, who reviewed it, when it was approved, and when it should be revisited. It also has an overview of the service that this SLO applies to. Then it comes down to SLIs. So these are the definition of the SLIs that we've seen previously, but here are the ones who actually inform this SLO. Then there's a section for rationale. Maybe there's something that you need to make clear to whoever is using this SLO, and this should be explained here. Error budgets we're going to see in a bit, but here we can describe what the error budget is for this particular SLO. And of course, you can have a section that has clarifications and caveats, something that needs to be explained, something or maybe some constraints that need to be taken into consideration when using this SLO. So going back to our previous point, what is an acceptable target? 90%, 95%, 100%? Of course, it depends. It will depend on your user needs. It can depend on your business needs. For instance, you might be in a highly regulated business that has many constraints. It can be informed by cost and many other things. But the point here is that it depends. But just for us to have an idea, let's see an SLO for uptime. Let's say that we define 3 nines, right? So the number of nines is something that it's spread across the industry. But for example, for an SLO of 3 nines, this means that I can have 8 hours of downtime per year. Just by adding a 9, those 8 hours go down to 25 to 52 minutes. And if I add another 9 or 5 nines of reliability, this means that I can only be down for 5 minutes a year. So just by adding 1 9 to my uptime SLO, I drastically reduce the downtime. So I have to put things in place so that I can ensure that I'm not down more than the allowed amount. So just to conclude this point, let's just do some back of the envelope calculations to see what does this mean. So I mentioned that you need to put things in place to actually assure this type of reliability. So let's just go through a couple of scenarios and see how much this could cost us. So let's see scenario 1. Let's imagine that I want to increase my reliability from 3 nines to 4 nines, right? So I'm increasing my reliability 0.09, and this means, and let's imagine that my service does 1 million of revenue. This means that if I improve my reliability, the value of improvement is actually $900. So does this make sense? Maybe. This will be up to you. But these are important to do these calculations to see if it makes sense. Scenario 2, let's use as rule of thumb. We can see a lot in documentation, and I believe it's also in the SRE book, that each additional 9 of reliability costs us 10 times to achieve that. So if I go from 3 to 4 nines, this means that whatever it costs me to run my services, it will increase by a factor of 10. So let's use exactly the same example, going from 3 nines to 4 nines, and let's imagine that it costs us to run $1 million. That means that by adding a new 9, it's going to cost me around $10 million. So this, of course, are back of the envelope calculations, but it's important to do this type of calculations for us to have an idea if I want to increase my reliability, how much will it cost me, and the amount of value that it can maybe get me. So moving forward, we touched briefly before about error budgets, but essentially an error budget is what is left from an SLO. So if I consider that 100% is that my service is always reliable, the error budget will be 100% minus what I define an SLO. So if it was 2 nines, it will mean that I'll have 1% of error budget left. So it's effectively the percentage of reliability left, and it can help us make educated decisions on whether, for example, to release a new feature or not, based on the amount of risk that we can take. They help make sure the operability process, for example, incident response, is appropriate to the budget available for the service being provided. What this means is that with the amount of error budget that we have left, we can inform our incident response. And last but not least, we have service level agreements that are well known to us, but essentially an SLA is nothing more than an SLO that has some kind of penalty attached. For example, let's use the same examples that we've been using up to this point. So if I can define an SLA that says that 95% of requests to a service need to be responded within 200 milliseconds, within a 30-day period. If that doesn't happen, the customer will get a 30% discount. And the same thing for the other examples. But the basic idea here is that an SLA is an SLO that actually has some type of penalty attached. They are usually looser than SLOs, so that if we breach an SLO, we actually still have some time before breaking the SLA. So looking at the first example, if we had an SLO of 2 nines, so 99%, this meant that if I breached that SLO, I still had 4% of unreliability to burn, so to speak, until my SLA was breached. So what can we build with all of this? So of course we can build visualization. So here's an example of how we can track and put on a dashboard a visualization of an SLO. Here we have the objective, for example, 99%, how much SLO is being burned, how much error budget I still have left, if something is burning or not. So this is very interesting, and we can see and can do an historical analysis of how my SLO is actually going. But we don't want to be looking at dashboards all day. This is very interesting, but what we actually want is to be informed if something is not going okay, right? So that we can take the appropriate measures. So we come to alerts. So if we think about the traditional alerting methods, we usually use metric thresholds, right? So we define some kind of threshold, and if something goes above that threshold, we need to trigger an alert so that someone can investigate and see if everything is okay. So here are just a couple of examples. If a CPU goes above 80%, if a certain number of requests is taking more than 200 milliseconds, if we have X amount of 500 responses, we just trigger an alert and someone needs to investigate what's going on. We can take the same approach with an SLO. So we can say that if latency, if we have an SLO of 99% and latency goes below that SLO, we need to do something. This is better because if we define our SLOs in a meaningful way, it's actually tracking user experience, but it only alerts us when we are already in trouble, right? So how can we do better than this? So we can alert on the amount of error budget that we still have available or the amount of error budget that we have already burned. So we can set alerts when available error budget reaches a critical level or when a critical amount of error budget has been burned. And we can set different trigger levels to different alert channels. For example, if I have already burned 25% of my error budget, I can send an email. 50% I can alert someone on Teams or on Slack, and if 75% of my error budget has been burned, I can trigger PagerDuty or OpsGenie for someone to actually look into it. This is better than the alternative because we are being alerted before we get into trouble and we need to do something, but we have no idea how fast this error budget is being consumed. So it begs the question: if my SLO is well defined, and if I could know if by the end of the evaluation period we would still have some error budget left, would you like to receive this alert? Probably not, because I will still be within my bounds of the amount of reliability that I have, so I can make the decision to actually, release more features or do other type of work because I still have some unreliability that I can account for. So the next evolution would actually tackle this problem, and it is the burn rate. So burn rate actually tells us how fast the error budget is being consumed. When I make this calculation, if the burn rate of 1 means that all my error budget will be consumed within the interval that I define, for example, 30 days or a week. Let's see this example. If I have a window of evaluation of 4 weeks, and I'll calculate my burn rate, and it's 2, this means that I will consume all my error budget in half the time. So in this example, 2 weeks. This is a lot better, but it still has a slight problem, which is if the error budget burns too fast and we evaluate it and for example it is consumed within my evaluation period, I might not even receive an alert. So we can do here a small tweak to have excellent alerts based on burn rate. And these are alerts on error budget These are alerts on multi-window, multi-burn rate alerts. So we'll use multiple windows and multiple burn rates to inform us of different problems. We will inform fast burn alerts that will alert us on sudden changes in the consumption of burn rate. We can think of this as an example. We have a huge spike in errors in our API, for example. And slow burn alerts that alerts us on less urgent issues, but it's something that is consuming over time a lot of error budget. So here are just a few examples. I can define that I have a window of evaluation of 2 hours. I evaluate every 5 minutes, and if my burn rate is 10, I know that something is not okay. And the same thing for a slow burn. I define evaluation period of 4 hours, so longer, and if my burn rate is is 2, I actually have a problem and I need to investigate. And our last concept is the concept of the error budget policy. And the error budget policy is nothing more than a document or a set of documents where we define what happens when certain conditions of my error budget have been breached. So here are just an example. So if a service has exceeded its error budget for the preceding 4-week window, we will halt all changes and releases other than P0 or security fixes until the service is back within its SLO. And depending upon the cause of the SLO miss, the team may devote additional resources to working on reliability instead of feature work. So this is a concrete definition of what happens when my SLO is breached. This, of course, will be highly contextual and will be dependent on your organization, of course, but it's something that it's predefined and it's agreed by everyone involved that if certain things happen, these are the actions that we are going to take. So to recap, let's see this concept of the reliability stack in his extended way. We started by looking at metrics, which are measurements about the system. We then evolved those to an SLI, which tells us if a metric is good or bad, or an event is good or bad. We then evolved into SLOs, and SLOs can tell us how many times the SLI needs to be good so that my customers are actually happy. The error budget is nothing more than what is left from the SLO. And then with SLOs, what can we build? We can build visualizations to actually, so that we can use to assess if the SLO is okay or not. We can build meaningful alerts that track user experience and tell us if something is not okay. We can define error budget policies that actually can inform us what we need to do if certain conditions happen. And of course, we can use the SLOs to define SLAs that are nothing more than an SLO with a penalty. And why is all of this important? For starters, we start measuring reliability from the eyes of our users. They are the most important actors that will help us define the reliability. It doesn't matter if my system is performant, if my users are not happy with the way that it's working. Also, reliability work ties directly to business goals. So happy users are usually good for business, and if I'm tracking reliability and my users are happy and I'm ensuring that my users are happy through a reliability framework, this is good for business and we can tie this directly to business goals. It also creates a shared language to talk about reliability. There's no more some engineers defining how reliability should be tracked or measured, other reliability engineers doing it another way, product people saying it another way, business people doing it another way. So now we have a framework that will help us assess, measure, and define reliability. And of course, this facilitates prioritization. So if we have a reliability framework in place and we have an error budget policy that tells us what needs to happen when certain conditions apply, this helps us facilitate prioritize work and makes it easier to make decisions on when should we focus our efforts into reliability work or on product work, for example. And this is all from my part. I hope this was informative for you. Don't hesitate to contact me through my social links. I hope you enjoyed my talk and have a great conference.